And today I'm pleased to introduce today's session, Multi-Agent Systems with Mistral AI, Milvus, and Llama Agents. And our guest speaker is Stefan Batipol. Stefan is a developer advocate at Zilliz. He previously worked as a machine learning engineer at Wolt, where he created and worked on the ML platform, and previously as a data scientist at Bravo. Stefan studied computer science and artificial intelligence. He is a founding member of MLOps community Berlin Group, where he organizes meetups and hackathons. He also enjoys boxing and surfing. Welcome, Stefan.
Thank you very much. Thank you for the introduction. Thank you all for coming today. Yes, we're going to talk about multi-agent systems with Mistral AI, Milvus, and Llama Agent. There is also going to be a demo that I'm going to do later on during this presentation, where I will actually show you how to build it. You will also see that, not everything is deterministic. So sometimes you have answers that you like, sometimes you don't. So I will hopefully have the right answers so the demo looks nice. But for the people that don't know me, I'm going to start by introducing myself. So yeah, I'm Stefan Batipol. I'm a developer advocate at Zilliz and Milvus. If you have any questions, you can feel free to send me an email or chat on LinkedIn or Twitter. I'm basically available everywhere. You can ask anything related to Milvus, ask anything related to AI in general, generative AI agents. It's usually the things that I work on. And before we continue, I'm gonna introduce Milvus a bit for the people that don't know what we're doing. Then we'll start and talk about the different agents. So Milvus, it's part of the Linux Foundation for AI and data. And we're the key maintainers of, Zilliz is the key maintainer of Milvus. And then, we are graduated from the Linux Foundation. We have a lot of stars on GitHub. We have more than 28,000. We also have a lot of people downloading it. We have more than 10,000 companies using us, I think, in production. But what is cool is that with Milvus, you can start with an easy setup, so a pip install to start, coding directly in your notebook. But then you can also move very quickly to then having Milvus deployed on Kubernetes, for example, or using Zilliz in the cloud. We also have integration with different partners, so OpenAI, LangChain, Llama Index, or different. And feature rich as well. So we support dense embeddings, sparse embeddings, filtering, re-ranking, and a lot of different things as well. Actually, today we'll see how we can do metadata filtering using agents, where the agent will actually create the metadata filtering by themselves. As I've said before, so we have integration with different AI toolkits. So LangChain, Llama Index, are the most two famous ones, but also DSPY, LangFuse, GenAI, Voyage AI, and a lot of different partners as well. So you can check out directly on our documentation, so milvus.io, and then you can see the integration we have with our different partners. I'm going to start by introducing the RAG concept, so because I'm not sure if everyone is familiar with it. Then we will quickly see the limitation of RAG, and then we will go more into the agentic part of it. So RAG, which is retrieval augmented generation, the basic idea is to force your LLM to work with your data. And how you do that, you do it by injecting it into a vector database like Milvus. And the basic architecture is this one. So you have your data, then you're going to extract some content. You're going to do what we call chunking, which means, getting some part of the data. And then you put everything through an embedding model, and then you store everything in Milvus. Once you have a query by your user, what you do is then, again, you're going to put it through an embedding model, the same one as you used before. And then you do what is called semantic search. So you're going to search for things that are semantically similar to the query. Then Milvus will return similar data. We will put everything back into the context for the LLM. And then the LLM will produce a response, and then we give this response to your user. So that's the basic RAG architecture. That's the one that it can do with basically 5 lines of code. That's one example. If you're using Llama Index, you're going to load your data, and then you put it in a vector store, and then you build a query engine, and then you can run the queries. And that's basically it. So that's very nice. That's a very quick one. With that one, if you have some documents you want to go through, it can be very useful, but it's usually not enough. because naive RAG is nice, but naive RAG is a bit limited, So it has different value modes. So one of them is summarization. So, because RAG is like closely related to semantic search, to summarize a document, you would basically have to fetch the whole documents. And RAG is not designed for that. So usually it can struggle with summarizing documents. Also, it can struggle with implicit data. So, if you ask a question, like for example, what is a company that has the highest revenue on the US stock? Uh, then it will do like semantic search on your data. But then if you don't have this information, then it will not know about it. So also your document really have to say it explicitly. So otherwise, if you don't have that, then you're likely not going to find it. So that's a problem you may have, where then you have to use different tools. It can also struggle with multi-part questions. So if you ask multiple questions, the RAG system might skip one, or you might not answer it properly. So that's also like a struggle of the naive RAG failure. So in a nutshell, RAG is very useful. Don't get me wrong, but basically it's necessary and not sufficient, because a lot of tasks are related to semantic search, but there are also other tasks, that might require more than that. And from now on, we're gonna check like how do we go beyond the limit of the basic RAG. But first, a reminder for everyone. I've been working in the whole ML field for like years now, and we used to have a thing which is garbage in, garbage out. And it's kind of a reminder now. It's like, good dishes come from good ingredients. So you still have to make sure that your data collection is good, the data cleaning is also good, and the parsing and chunking are good. You can't really expect your RAG system to perform if your data collection is not good. And like then the cleaning is not good, like then the LLM is going to be confused by a lot of things that are going to make some noise for the LLM. And then same for chunking, if your chunking is a bit too small, or it's too big, then your LLM will also get confused. Like, if basically the way to see it is that if you yourself can't understand the chunks, and can't really understand the context, then it's going to be very hard for your LLM to do it. So now, if you have like different documents, for example PDFs, given the capacity of LLMs now, one page can be a good one. But then you might also be able to to chunk through paragraphs, or then create some super chunks and create some smaller chunks, or then have a summary chunk and then a smaller chunk as well. Those can be really useful for your LLM. If you don't want to struggle with that, we have what is called Zilli's pipeline. So that it's available on Zilli's cloud, and we basically have state-of-the-art ingestion pipeline. So then you have like good chunking, so you don't have to struggle then with having bad chunking and then having a bad RAG system for it. But just to come back, naive RAG, that's a naive RAG pipeline, and that's good. But it's only single shot, meaning that every question is brand new. There is no memory of the previous question. It has also no query understanding, no planning. It doesn't use any tools. It also have no correction, no error corrections, and it has no memory. So it's like a lot of things that it doesn't have. And it's really like every time you're going to make a query, you have to go through your RAG system again, whereas you could use something in memory, for example. So when you want to improve that, one thing to remember is that you really want to measure how you want to improve it. That's a different talk. But like, yeah, keep in mind that, if you really want to work on something and measure how to improve it, you have to measure it. It can be with like, having some golden data set, basically, where yourself, the answer, and then you're going to check your RAG system if it's actually answering the question properly. And then you can also use LLMs to evaluate LLMs. There are a lot of like documentation on the internet about that, so you can have a look. But now let's talk about Agentic RAG. So that's the new cool one in town, basically. And Agentic RAG, it's multi-turn. So, you can have agent understand the question and then plan with multiple steps. So that's something that is like very good. It also has some tool interface for external environment. So if you need to browse the internet, then the agents can then decide to actually use this tool to then browse the internet and then get the data back and then, for example, integrate it into the context of the LLM so you can give an answer. It also has reflection, and then it also has memory for personalization. So that's you can see now it has like it can be way better. And it's not only going to be single shot, you can actually, like your agent will use a tool that is going to then, call the RAG, and then you can go back to the agent, and then you can loop through that up until you're happy with the answer, actually. So they're like different ways. The first one is self-reflection. So you have your query, and then you're gonna have like the chunks of your documents, and then you're gonna check, you're gonna get the top K relevant chunks, and you're gonna make sure like, okay, some of them are correct, but some of them are ambiguous. So then for the one that are ambiguous, what you can do is that then your agent can search the internet to verify, and then like then it can compare the data it has on the internet with the data you have in your database. And then you can be like, okay, actually, it corresponds to what I have in my database. I have 5 different results from 5 different websites. They kind of like say the same thing. So then I'm pretty happy with it. Then I can give back the answer to the LLM and then give back the answer to my user. So that's one. Then you also have what is called query routing. So, it's going to be like you have your query and then you put it through your agent. And then your agent would be like, oh, do I need to like check my database for that? Or do I go directly somewhere else? So that's like if for example in your database you have data about, I don't know, financial situation of different companies in the world, and you ask your agent something about zoo in the world, then it will know that it doesn't have this information in the database. So instead of just doing search, it will skip that part entirely, and then it can do like different things. So you can go on the internet and check about zoos different like everywhere. So that's also like a part that is possible. So that's query routing. Then you have query routing with subquery. So that's also like one that is very useful. So instead of having one query, then you can divide it into different ones, and then it will then make the search for the different queries. So if you have different questions, for example, what is Milvus and what is Zilliz? Those could be like 2 different questions. So then the first one would be what is Milvus, and then you'll have the second query, which is what is Zilliz, and then you do vector search on both queries, and then you get the top K of both answers. Then you combine those two to the LM, and then you give it back to your user. Sorry, as an answer. So those are like different ways of like having better results and treating complex queries. Then you have also conversation memory. So, you have your query, you put it through your RAG system, and then you store everything into memory. So you basically pass the history back to your context. And that's an example of like how chat works in ChatGPT. So the only thing you have to be careful here is that in practice, so like you put more context to the history, but then you can also overflow the size of your context window. So you have to get clever, and maybe you have to condense the history a bit so it can still fit. You can't just like append and append and append, because at one point, you will just become bigger than your context window. So you just have to always remind that. And then we have what is called React prompting. So that's reasoning and action. So this one, it's basically designed to integrate the different reasoning capabilities of LLMs. And it's also possible to like take actionable steps. So if you make a query, and we'll see it live later during the demo, but if you make a query, then it will be like, okay, for this query, I need to use this tool. And then it's making sure that you're actually answering the question. And then if you are answering the question, then it will give you a result back. And by doing that, it's able to understand and process information, really evaluate situations, and then it can also take appropriate actions. It will also communicate some responses to you, and then it's really also keeping track of the situation. It's really keeping track of, oh, okay, my first question was, what is Milvus? Then I'm asking that. And then, I'm using a different tool that is like browsing the internet. And then I'm just still tracking to see where I am and if I have answered actually the user. In practice, it looks like that. So you can see the first thought, like it's a question about Apple Remote, and then like we can see like the first act is actually searching for Apple Remote. Then you have an observation, which is the result of the search. So it's the Apple Remote, the remote control. And then you have a second thought because then the LLM is not really happy with the answer. So then it's really again, like gonna do another search, which is about front row. And then, for example, here you can't find front row. So then it's like, searching for something similar. So then it finds front row software, which is similar. And then, like different things. So then you have like a different thought. Then you search for front row software. And then finally, you have the final thought, which is front row software is controlled by an Apple remote or the keyboard function key. And then you have the act, which is finishing. And so then you can just give that back to your user, and then you can be like, okay, actually, the result is keyboard function key. So yes, that's basically how React prompting works. And again, you'll see it in action because it's what I'm using for my agent later on. And then I said it multiple times, but like Agentic RAG allows you to use tools. So let's say, you might be able to, you have a query and you want to have auto retrieval. So then you can have your query and then your LLM will actually generate this query, like for the metadata, for example, and everything. But then you could also have something that is, generate some SQL from text. So then you have your query, which is text. You put it through an LLM, and then it will give you some SQL that you can then run, and then it will give you the answer. But also you can use like different tools. It can go through like calendar. So like if you connect it to Google Calendar, then you can be like, okay, I need to check if Stefan is available tomorrow. So then it will infer the API as well for Google Calendar, and then it will give you a result. And then you can then give that answer to your user. But basically, that's Agentic RAG. Now I'm going to go a bit deeper about how I actually built everything. So we're just going to talk about the stack, and then we'll go directly into the demo. So for this one, I'm using first Llama Index. So Llama Index is a framework for building LLM applications, and it's really focused on like retrieving data and integrating with different LLMs. It has integration with lots of AI tools. So like really, really lots of AI tools. But recently they released something which is called Llama Agent. And Llama Agent is made by Llama Index as well. It's open source. And it allows you to build stateful apps with LLMs and multi-agent workflows. You have also scikit-learn branching. You can have human in the loop as well. It allows you to have persistence. So let's say, you built an agent system and you work, I don't know, in customer support. Then before actually, issuing, I don't know, like a new ticket or something to your customers, you can actually ask for human to validate it and can be like, okay, please here we stop and we ask the human if this action should actually happen or not. And then if it happens, if the human says yes, then we can continue the action. So that's like one thing it allows you to do, but it's really good at actually organizing multi-agents. And you have like, you can see on the right side the components. And I'm just going to zoom in on that one. So on the component parts, you have the user, and then you have the control plane as well, which is has like everything. So this one, the control plane is really like the central gateway to the Llama agent system. So it really keeps track of the current task as well as the services that are registered to the system, and it's also the one that is holding the orchestrator. And the orchestrator really, it's really like the module that handles incoming tasks and also decide what service to send it to. So like also how to handle different results from services. And orchestrator can be agentic. So either an LLM is making the decision, or it can also be explicit. So then you can define a flow, and then like you can go through something that is very specific. Also, it can also be a mix of both if you want. Then you have the different services. So you can see like the different agent services here. So that's basically where the work actually happens. So like a service accepts an incoming task and context that you give it to, and then it processes it, and then it publishes everything as a result. And a tool service is basically like a special service that is used, to offload competition of agent tools because they can also be very heavy, and everything. So that's Llama Agent. That's what I'm going to use later on, and that's the different components. And by doing that, also by having agents that are like really different, on individual levels, then it can also scale up and down different agent services. So that's also very handy in some cases. For the LLM and the embedding model, I'm going to use LLMs from Mistral AI. So for the people that don't know, Mistral AI is a French-based research lab, and they recently published like open source models. They're really focused on having open source models. Actually, they released two in the last couple of weeks. So the first one is Mistral Nemo, which is a 12 billion models with 128,000 context length. And it's really strong at function calling and retrieval for its size. Also, you can run it locally with Ollama, for example. So that's what I'm going to use. And then for like more complex tasks, I'm going to use Mistral Large 2, which is 123 billion parameters with, again, 128,000 context length. And this one is also been fine-tuned on actually being able to use function calling and retrieval skills. So those are really, really good for RAG and function calling. And then for the main model, I'm just using the one from Mistral because it's also been focused on retrieval, which is very useful for RAG. Unfortunately, when I checked, it was English only. So if you have something in a different language, you might need to use a different embedding model. I am also going to use Milvus Lite. Everything from Milvus will run on my laptop. So with Milvus Lite, what's good is that you can just run a pip install by Milvus. And then everything you have like basically Milvus lightweight on your laptop. And then if you want to use then Milvus as in the cloud, you just have to change the URI of the code. So, we'll see it's a local file that I'm calling. But then if I were to have something on Kubernetes, then I need to put the URI of the cluster. And if I have Zilis Cloud, then it's the same. So you basically only change one line of code, and then everything else is supported. And yeah, now it's going to be demo time. So let's see if actually what I want to show works. Because disclaimer, so my agents are like everything is non-deterministic. So usually it works, but sometimes they decide that they don't want to do what they're supposed to do. So that's also like a big problem of using agents in general, is that yes, it can be very handy, because then you can like really make decisions on its own, but sometimes it can also be capricious. So let's see what we have today. But yeah, let's go. So I have this demo, and then this one is using Llama Agent with Milvus and Mistral. So Milvus, I talked about it. So this one I'm using Milvus Lite. And then I'm going to use Llama Agent. So my agents are running our microservices. And then I'm using Mistral AI and the different models. And yes, basically we'll see. So we'll get some data from the internet. Then we will store it into Milvus. We'll use Llama Index with Mistral for data queries. Then we'll create an automatic data search and reading agent. And then we'll have an agent that is creating metadata filtering based on the user query. And then everything is done automatically, So you'll see. And then, yeah, everything should work. So just for the sake of the demo, I'm just not going to install the dependencies because they're already installed. But you can see like it's a pip install Llama agent and then by Milvus as well. And by doing that, you just install Milvus Lite. And then here I'm installing the integration we have with Llama Index. Also like, being able to read files. And I'm also using Ollama to run Mistral Nemo locally on my laptop. So then I'm installing it as well. And then the integration with Mistral AI. And same for the embedding models. I'm just going to run this one because this one is needed for Llama Agent when it's needed basically because otherwise async IO in notebooks are not happy. So I'm just going to say this one is only needed when you run the code in a notebook. I'm going to import my API keys from Mistral. So if you don't have any, you can go on their website and get it. But that way, just like I have a file locally, which is an N file, and then it's just reading credentials from there. I have this data, which I will show you, which is financial data from Uber and Lyft. I will just show you a glimpse. You can see it's like from the Security and Exchange Commission in the US. This one is about Uber technology and it's the annual report. And we have another one which is from Lyft, which is the same, like very similar format. And this one is about Lyft. And we can see like different, like a lot of documents. And it's 238 pages long, and the other one is 300 pages long. So those are pretty long documents. But I will store everything into Milvus anyway. So given that I've already downloaded the data, I don't need to, but from now on, I am going to prepare the embedding models. So I'm using Mistral Embed, as I said, because it's developed by Mistral. And given that I'm going to use Mistral models, I was like, okay, maybe let's use those ones as well. So I'm just defining, the default embedding model that we're going to use for Llama Index. So I define it here, and then I'm just saying, okay, please use Mistral AI embeddings with the Mistral embed model. Then I'm defining the default LLM model as well that I'm going to use. So I've said it multiple times already, but I'm going to use Ollama. And Ollama allows you to run models locally on your laptop. It makes it very easy as well. And then, by default as well, again, I'm saying, okay, we're going to use Mistral Nemo. So Mistral Nemo is the 12 billion parameters model. So now I'm going to instantiate Milvus and I'm going to load some data. And we have it here. So those are the two files that I've shown before. And then here we're creating Milvus. So we have the Milvus vector store, which is the direct integration we have with Llama Index. And then you can see here the URI. The URI here, it's a local file. And when you define the URI here as a local file, then Milvus knows that it's going to use Milvus Lite. If you were to want to use something on Kubernetes, then you have to change the URI, and then it would be, I don't know, it would be cluster.gcp.eu west 1, for example. And then if you do that, then it knows, okay, actually I need to go somewhere else and I won't use Milvus Lite for this one. But I'm just going to go back to this. I'm putting the dimension of 1024 because that's the dimension of the embedding model by Mistral. I'm saying overwrite true because I like to live dangerously. So I'm actually going to overwrite everything I have in my database. And then I have a collection name, which is companies docs. Sorry. So it's just the name of the collection. Then I'm going to create a storage context with Milvus as a vector store. And then I'm going to load the data directly. We're going to use we'll load the data into memory. And then we're going to build the index. So when we build the index, we are actually saying, okay, please build an index with the documents that I have in memory, and then use the storage context that I've defined before. And this one is the one where you have Milvus installed and everything. And then here, I then define the query engine. So I'm going to run it. It's going to take a tiny bit of time, but it shouldn't be too long. And then, yes, here is the query engine. Basically, I'm saying, please only return the top 3. We don't need to return, 10 results or something. So for now, it's building the index. So I'm just going to move on in the interest of time. But from now on, then that's where the cool part starts. So that's here I'm defining the different tools that the LLM can have access to. So this is then, where if you want to have a tool that is, browsing a specific database, or another one is then, connecting to Google Calendar, that's how you define them, then. So this one, I'm defining a query engine tool, and it's actually only about Lyft. So it's only about the Lyft document. And it's going to provide information, then I have to write a description so the agent then knows which tool to use and when. So it provides information about Lyft financials for the year 2021. And then I'm saying user the type plan text question as input to the tool. And also I'm saying, please do not attempt to interpret or summarize the data. I just really want it. Um, and then we have the same one for Uber. So it's like it's the Uber 10K. And then here it's like gonna be like provide information about Uber financials for year 2021. And then the other questions are the same. So I'm just going to define those ones. So now they're defined, but then I need to tell the agent actually that they can use those. So I'm setting up the agent here. So my LLM is again the same, it's Mistral Nemo again that I'm running locally. And then the agent is going to be React agent. So React, if you remember, it's what I've shown you before, where then, you use the LLM to then actually making the decisions, to think and to divide the query to make sure you're actually answering the question. So that's what we're going to use. Then I'm saying, okay, we have those tools available for you. So the query engine tools is what I've defined above. So it's the two tools I have here. Then please define the LLM, and I put variables true just so you can see better what's happening. And I have a question, which is, could you please provide a comparison between Lyft and Uber's total revenue in 2021? And then we're going to have a response. So we can see here, that's the input we give. So that's exactly what I wrote. But then we can see the thought process of the LLM. So the user has asked a question in comparison between Lyft and Uber total revenue in 2021. I need to use tools to find this information. So then it's like, oh, actually, so I need to use the first tool that is defined. So it's Lyft 10K, which is the one that I've defined above, which is this one. And then it's giving the input. What was Lyft total revenue in 2021, sorry. So this one, I haven't written it myself. It's really the LLM that has then divided the question into two different questions. So it goes through our documents. The observation is here. So Lyft total revenue in 2021 was 3.6 billion. And then it's like, okay, now I need to find out Uber's total revenue for 2021. So then it also goes through a different action, which is Uber 10K, which is a different one. And then it changed my question to what was Uber's total revenue in 2021. Then it finds the answer. Uber's total revenue in 2021 was 17 billion. And then it's like, okay, I'm happy. I've gathered all the necessary information. The user's language is in English. So I can now compare Lyft and Uber's revenue for the year 2021 because I have both of them. So the answer, you can see it here. In 2021, Lyft total revenue was 3.6 billion compared to Uber's, which was 17 billion. This shows that Uber had more 4 times the revenue of Lyft that year. And then that's basically the answer we give back to our user. So that's the whole verbose mode, sorry. But if you didn't have that, then you wouldn't see it, but then you would basically get the answer. Okay, it was 3.6 billions and Uber was 17 billion. So you've seen now how LLMs then can divide the question into different queries when it makes sense, and then it can sometimes really think. But no, that's cool. But like imagine I had to create two tools now for two documents. So that's what I have here. I have this one, and then, but imagine if I had, I don't know, 100 companies or 1,000 companies. Imagine I'm a financial analyst. I don't want to have to create different tools, for all companies. What I would like to have is to have one tool, which is all about like, all the companies I have. But then I can create some metadata filtering. So, I can filter through company names, for example, or through document names to only then search through the data that I want to access to. If I want to search for Uber, then you should only search for Uber. You shouldn't have to search through all the collection. So that's what I'm going to try to do now. And yes, basically that's what we have. Like you have better precision, more efficient, and then you can customize different things. So here I'm showing you an example of how to use metadata filtering when you know what you want to filter on. So this one, we're going to filter on the exact match filter, which is the file name. And then I want to have Uber 2021. So we really filter only on this one. Actually, I want to do Lyft. No, let's do Uber. So we have Uber, and now we have a filter that is created. So I'm creating an agent again, and then we're gonna interact with this. So with this one, I'm gonna ask what is the business overview of Uber, and my metadata filtering is only on Uber documents. So I should find something. Let's see. Now it's gonna take a bit of time. And the other question I have, it's the same, but it's about Lyft. So I'm going to run both of them because it's a bit slow. But then let's see actually if my agent finds the data with, like the metadata filtering that I have. So also you can see, so, I ask my question and then he's like, I need to use a tool. And then the tool it's using is company docs. It's the new tool that I've defined, which is the one, that is more broad. It's not really specific about a company. So we can see some observation now about Uber. And yeah, then it's really like going to continue on that one. This one can be very long, depending on like if the agent is happy about the answer. And I'm not sure the agent is going to be happy because it seems to be looping about, about the action. And that's a bit of the problem that you have sometimes when you use agents is that, they sometimes they're not exactly happy with the answer. Then they're going to loop and then they're going to try to find something, like really try to find an answer up until they reach the max iteration. So it seems like that's what it's doing now. And I guess that's part of the demo effect. But otherwise, you can see, like the observation is actually correct. Like if I ask for like a business overview, it's a global technology platform that connects different things. But yeah, I'm gonna just keep that in the meantime because it should finish in a bit. But then what I want is that, I want to use an agent to extract metadata filtering. Because, like if you look here above, I've defined it manually here. I've defined like the filters. But again, I don't want to have to do that with like everything. I want to just type a query. And then with my query, then I can have like the answers directly. I will likely check this one. I think I will stop this one soon. But otherwise, I'm going to show you. And if it's not done, then I'll stop it. And then we can go back to this one. But here, that's where I have a prompt. So I have a prompt template, which is, telling the LLM, hey, please, given something specific, then you can make some actions. So for this one, I'm giving a question to my LLM, and then really it's like given the following question, extract the relevant metadata filters, like consider company names, years, and any other relevant attributes. So it's just, to tell the LLM what I consider metadata filtering and what I consider important. But also, then I'm like, please don't write any other text. I actually just want a metadata filter object. And then I'm like explaining how to format it because it maybe doesn't know about like metadata filtering and this object in particular. So it's like, okay, format it by creating a metadata filters like shown in the following. So that's what I have here. This one is an example that I used above as well. So it's like metadata filters with the different filters. And then if you don't have any specific filters that I mentioned, then you return an empty one. Then I'm giving the question, and then I return that one, basically. So that's what we have. And then I'm going to use Mistral Nemo again. And then we have an answer. And then I'm just checking. Basically, here I'm evaluating the answer to actually build the object in Python and then use it. But I think this one is still running. So yes, this one is unfortunately still running. I'm just going to stop it quickly. So I guess that's part of the demo effect. I'm going to restart my notebook quickly. Sorry for that. Because otherwise he will not be happy. I'm going to go through that very quickly. So those are like the tools that I define, my agent again. And I'm just gonna skip this one because it seems like it's looping and I only have 10 minutes left. So I don't want to wait for that long. But the idea is then, then he can't really find the answer for Lyft because I filtered on Uber. So I'm going to run this one after. And then once it's running, then we can ask the question, which is like, what is Uber revenue? And then for this one, it's not smart. My agent is not smart enough yet to infer everything because I have some, my metadata keys are very specific. So like it's really like file name and then it's the name of the file. But then it really depends on the metadata filtering you have, basically. So for this one, I'm like, okay, this should be in the file name Uber 2021 PDF. And then once we have that, then we'll see it should actually be able to have metadata filtering if it works. But now I have a bit of the demo effect. So I'm just trying to check where are we in my agent. Okay, so now we're comparing everything again. So, and you can see as well, you'll see that the answers are actually different to the one we had before. So before, it was way more verbose, and this one is just like, for example, 3.7 billions. And now it seems like can't format the output. But let's see if it still works. And yeah, basically that's what I was saying at the beginning, where like those agents can work amazingly well, but then not everything is deterministic. So then it really depends, on the agent and the action it's taking. And this one, yes, we should find the answer very quickly. And then we can go back to the live demo. Sorry. Yay. Yes, we have it. Okay, cool. And you can see the format is different as well to what we had before. But let's go back to our live demo now because that should be done. Yes. So that's what I was saying. Here, I create the metadata filtering. And then you can see actually the answer is this one. So the answer is metadata filter with a key file name and the value Uber 21 PDF. And that was created by the agent itself. And so then I can, run the same question. And then here I have my engine tool. And then I say, like it's company docs filtering, that's the name. But then here I don't write anything about the companies, I'm just like, hey, please, it's provide information about various companies financial for the year 2021. And that's what it's doing. And then now putting everything through my agent again, and we're checking for the answer. And here it's really like, okay, the user has asked about Uber's revenue, which can be found in the provided PDF. I'll use the company docs filtering tool for that. And then it's again asking the question, and then it's finding the answer as well in this document. And now it only search actually in the Uber document. There was nothing about Lyft and everything. So now, just for like the bigger part, basically, because I haven't used Llama Agents yet. So Llama Agents is now coming into play. So that's the one where, like then you can orchestrate everything. So, I've shown you different examples or smaller tasks. But if you really want to have an agent that works and that does like a lot of different things, then that's how you would define it. So you have Llama Agent, and here you have, like Llama Index with the agent as well, function calling worker and Mistral AI. So if you remember the graph that I had before, so I have this message queue as well that is like, using to talk to the different agents. Then I have my control plane. This one is where I'm using Mistral Large. And the reason I'm doing that is that the control plane is really, the head of everything. So it can be useful to have an LN that has like bigger and better capabilities, basically. Then here I'm defining the tool services, with the different query engine tools. And yeah, here is just like different tools, so like those are meta tools basically. And finally, I define the agent, and I'm going to use Mistral Large again here because I need a model that has like very good capabilities of dealing with agents and function calling and reasoning. So that's what we do. And then I'm just defining, the description. So now that is defined. I'm just changing the logger level so you can see everything. And now I'm going to launch it basically. So we have the agent server, the different tools, control plane, and the message queue. And then I can ask, for example, what are the risk factors for Uber? And I can see, so we have the agent service, and then, the different control plane. We're publishing everything to the control plane with you have to create actually a new action. You have to create a new task. So then you go for an action. You're creating an agent. Then you publish again. Then you create different tasks. I'm not going to go through everything, but that's how it works. And then here, that's where you're okay, actually, I think I found the answer. So it seems like you send back to the control plane. Okay, that was completed. And then you do different other actions, and now it should be done. And we can actually print it. Oh, it's not done yet. Okay, no, this one is done. So this action is done, and then it's really during different calls, and soon enough, this should be done if it's actually working at one point. But yes, that's basically what's happening. Is that then it talks with the different agents and talk to the different services, and hopefully it will finish at one point. But otherwise, that's I'm gonna come to the conclusion because I have 10 minutes left. But that's basically the idea of how to use Llama Agent to create different agents and using Mistral as well to to orchestrate everything, and then you store everything into Milvus. And yes, basically, if you like this tutorial, even though there was a bit of demo effect, you can still give us a star on GitHub. We'll really appreciate it. That's really is helpful for us. And then if you have any questions, you can also add me on LinkedIn, and I'll be happy to answer your questions. And that's it. Thank you.
Okay, cool. Thank you, Stefan. You have a few questions in the chat, so I'll just go ahead and ask those. So to run this RAG service using Llama and Mistral API, do we need GPU-based server or CPU-based is good enough? And then share server VM, CPU and men size used for this demo.
Okay, everything's broken now. But we can just use CPUs for this one. Everything is running on my CPU at the moment. And then a small laptop is working as well for models that I quantize.
Okay, thank you. And then for Milvus on-prem deployments, what are the recommended embedding models and LLMs suitable for Milvus?
I mean, we support everything, so then it really depends more on your use case. Embedding models would be, I don't know, it depends on the language, for example. It depends on what you're doing. You can also depends on how much resources you want to spend. But some models, for example, would be very good in German or French. Some models have been trained on English only. So Mistral, once you embed everything, then we can store everything into vectors. So then it was good.
Yeah, and I also shared a resource in the chat of AI models for your Gen AI apps. And then there's also a blog of choosing the right embedding model for your data. So you can check that out on our website. I shared that link. And then another question you have is, would it work to set temperature equals 0 to make the agent's LLM as deterministic as possible, thus achieving more deterministic behavior?
Yes, that would be very helpful in general. It depends on I mean, yes, that would be very helpful to be more deterministic. I think I had changed the temperature at one point. I was not too happy, but I will try with 0 again.
Okay, thank you. And then someone's asking, could this notebook be shared to the participants? So it's going to be on our bootcamp, on the Milvus bootcamp. Stefan, do you have a time frame, maybe within the next day or so?
Yeah, end of the week.
Hopefully.
It's in peer reviews at the moment, so that's why.
Yeah,
then once
and
it's published,
this whole recording is going to be posted on YouTube, and that the notebook will be in the comments. I mean, in the description, so that you can go back and check at the end of this week if that's up there. So thank you for your patience on that. And then the next question is, can we implement some breaking logic for agent? Example, give up after n attempts and generate answers.
Yes, there's like some parameters. You have like max iterations. For example, you can set for your agent, so then like you can like stop after 3 or 4. Also, depending on your prompt, you can also tell your agent, please, if you don't know at one point, just stop and give an answer saying you don't know. That's usually how it works, except when you have a demo effect. But yes, for those usually yes.
Okay, cool. If anyone has any other questions, please leave them in the Q&A tool. A question I have is, what are the considerations for choosing between different LLMs for various tasks within the agentic system?
I think it's really depending on like what the LLM has to do. So if it's like about some small task where you don't need a lot of reasoning capabilities, then a small model might be very useful, might be enough. You can have it running locally. But then if you need something where it has like a lot of reasoning capabilities, it's gonna go into like different functions, it's gonna call different agents, then it might be good to have a look into bigger models. So, like for example, Mistral large is 123 billions, but then you can also think of like Llama 3.1 for 100 billions, and those can be very very useful as well. It's just more expensive.
Okay, thank you. And what are the benefits of using a big LLM for high-level decision making while delegating specific tasks to other agents?
I think it's kind of repeating myself here for this one, but it's gonna be like you're gonna save money and time if you use a smaller LLM for the other task, because also big LLMs can be very slow at processing things, and yeah, it's way more expensive as well. So like time and money basically.
Okay. Does anyone have any other questions? Please feel free to ask them. I see one more here. If you already host Mistral LLM locally, what is the Mistral API key used for in the notebook?
It's used for Mistral large, so I can't run the 123 billions model locally. So if like in the demo, that's what I have here. Unfortunately, it crashed, but that's what I had here. Otherwise, it's really controlling everything. So the control plane with the agent orchestrator. Here, I'm using Mistral Large, and this one is too big to run on my laptop. So that's why I have the API key, and also for Mistral embedding models, because this one is only there.
Yeah, sometimes the demo gods are not in our favor.
Yeah, and this part has never crashed, and I was like, yeah, let's go.
Of course, when we're recording, this happens. Um, yeah, thank you so much, Stefan. We will end this webinar a little early, so thank you so much all for joining. You'll receive the recording and the slides through email later today. And look out on YouTube and our Milvus bootcamp for this notebook to try this out yourselves. So thank you all, and thank you, Stefan, for hosting today.
Thank you. Bye.
Bye, everyone.